Hello, everybody. I'm going to do some exercise on the second order linear differential equations. And this is the non-homogeneous case. Previous than this video, I explained how to calculate the homogeneous solutions for second order linear ordinary differential equations. Since the solutions are so long, I am going to divide a few videos on how to solve these questions. In the general, what we are going to do, how to solve this kind of equation, is we first calculate the homogeneous part. So that we assume that fx is equal to 0 and calculate the solutions for this part. So let's call this homogeneous part solution YH. And then what we do, we have this function fx. For fx, we guess a more general format of the function and then substitute in, derivate and substitute in, and calculate the particular solutions for the non-homogeneous part. And let's call this part as YP. And the general solutions for the whole of this kind of equations are given by as a summations of these two parts. So Y, the general solutions of this, is the homogeneous part plus the non-homogeneous part. In the computations of such calculations, what is involved is finding a guess functions for the right-hand side. So if you have a polynomial, and this is a situation, this is just an explanations in general form, is like a theoretical way of doing it, then we will do exercise on it. So P is a polynomial. If you have something like that, this is a polynomial, right? This is an example of a polynomial. So this is third order polynomial, degree 3. And the general form for the degree 3 polynomial is given by ax cubed plus bx squared plus cx plus d. So this will be the guess function. And if you have a polynomial times e to the Sx, for example, then your guess will be general form for the polynomial Px. So generalize that as we've done here, and then take the e to the x. Sx exactly the same. So if you have, for example, 5 e to the ex, then the general form a to the ex. So if you have a polynomial in the beginning, then you will generalize it and then multiply e to the sx. If you have cos x and sin x, sin x and cos x will be generalized from some constant times co-x plus some constant times sin x, or if both of them have the same guess, similar guess functions. Again, if you have a polynomial here and there, you will generalize your polynomial in a general form. Let's do some exercise and solve some questions. Okay, so this is our linear, second order linear differential equation. We have non-homogeneous case because right-hand side is non-zero. The solutions will be non-homogeneous solution plus the non-homogeneous solution plus the homogeneous solution. And we are going to deal with the guess function. It is a constant times exponential function. So the constant term is a degree 0 polynomial. The general form of the degree 0 polynomial is just a constant. So the guess for the right-hand side for this kind will be a constant times e to the 4x. Okay, and for homogeneous part, we will find a first characteristic polynomial, as we've done in the previous video, as we've shown in the previous video. So that is lambda squared plus 3 lambda plus 2 is equal to 0. And this second or quadratic polynomial can be written in terms of linear polynomials, lambda plus 2, lambda plus 1. So that is lambda squared, that one. 2 lambda plus lambda will be 3 lambda, and 2 times 1 is 2. So this is the correct linear factorization of this correct quadratic polynomial. From the first linear factor, we have the lambda 1 is equal to minus 2 is a root. Lambda 2 is equal to minus 1. So we have two real distinct roots. If we have two real distinct roots, then the homogeneous solutions are given by constant times exponential function, first root x, plus some other constant exponential function, another root x. And that's exactly that. So a and b are any real numbers in this case. So that is YH, that is a homogeneous solution. Now we need to do the non-homogeneous part, use our guess function, derivative, and this guess function has to satisfy this equation. So if we take the first derivative and second derivative and substitute in, so this equation needs to be satisfied. And that will help us to figure out this coefficient A. So this is the procedure for the second part. Okay, so this was our guess function. The first derivative will be 4a e to the 4x, and the second derivative will be 16a e to the 4x. And we want to find out a. So this is our equation. So we substitute in these values. 16a e to the 4x, 3 times y prime will be 4a e to the 4x, substitute in, plus 2 times yp is a to the 4x. Now, this is the right-hand side. The key on this computation, you're not going to touch on the right-hand side. What I mean by that, you're not going to move or do any computations on the right-hand side. You will leave it like that. You will organize terms on the left-hand side and make the coefficients are equivalent. That's the way to solve this. So if we organize the left-hand side, we have 16a, 12a plus 2a, and we have 10, 20, 28, 30. We have 30a on the left-hand side, e to the 4x, and the right-hand side, 30 e to the 4x. As I said, this coefficient here is equivalent to this coefficient. In this case, a is equal to 1. And the general solutions for the whole equation will be y is equal to yh plus yp, homogeneous, non-homogeneous part. This was the homogeneous part, and the non-homogeneous part will be just, since a is equal to 1, that's e to the 4x. So that's the general solution. Okay, let's do another example. So that's a question. In this case, on the right-hand side, we have x times e to the 3x. So x is order 1 degree polynomial. So the general form of degree 1 polynomial is ax plus b. So our guess will be yp is equal to ax plus b times e to the 3x. Right. Okay, first homogeneous part, the whole solution is, we said, is a homogeneous part plus non-homogeneous part. First homogeneous part solution. Find out the characteristic polynomial. Y square, y to 2 prime, lambda square minus 4 lambda plus 4 is equal to 0. What is the linear factors of this polynomial? Lambda minus 2, or lambda minus 2 squared. So we have one root with multiplicity 2. That is one root with multiplicity 2. Then the homogeneous solution will be given by this formula. That will be a constant plus bx e to the minus 2x. So the formulas for the homogeneous solutions are given in the first video. We know that. We know these formulas from there. For non-homogeneous part, so as I said, this is the degree 1 polynomial, and the generalization will be ax plus b, and we e to the 3x stays as it is. Now, this equation, this function satisfies this whole equation, and using this knowledge, we are going to calculate a and b. So the first derivative, since you have a function depending on an x here and here, so it's a product of two functions depending on an x, it means that we need to apply the product rule. Okay, so the derivative of this will be a, with respect to x, will be a e to the 3x plus derivative of this times this. This is 3 times e to the 3x ax plus b. Let's tidy up a bit so it will be easier for taking the second derivative on the next step. A to the 3x, and we have the under the bracket 3ax plus 3b plus 3a. And as we take the derivative, derivative of this, derivative of inside, I think that's what I've done here. Derivative of this polynomial with respect to x is just 3a, that's 3a e to the 3x, plus derivative of this will be 3 times e to the 3x times the whole of those. Okay, so we have y prime, y2 prime, y prime, y2 prime. We can substitute in. We substitute in this equation. So this is our original equation. Okay, and so we have, since we have e to the 3x in y2 prime, y prime, and yp, and on the right-hand side as well. So we can eliminate that. So we don't need to repeat to write it down again. In this equation, I'm just writing down all only non-e to the 3x terms, if you like. Okay, y2 prime is this one, except the e to the 3x will be 9ax, which is that guy. Yeah, so this is that one, 9ax is 6a plus 9b. Yeah, this will be the y prime, y2 prime, minus 4 times this guy, 3ax plus 3b plus a, plus 4 times this polynomial, ax plus b. On the right-hand side, I have only x. Again, the similar idea, I'm not going to do anything with the right-hand side. I will organize the left-hand side and try to find out a and b. And the right-hand side is the polynomial is like a 1 times x plus 0, right? The coefficient of x is 1 and the constant term 0 on the right-hand side. And I will do the same thing for the left-hand side, right? I will write it down left-hand side as x times something plus the constant term. So the coefficient of x will be 1, and the constant term, as I said, this whole thing will be 0. So that's the key idea. And that will help me to find out the constant terms a and b. Okay, so we have x here, and we collect the x terms. X terms, we have 9a here, minus 12a here, yes, and plus 4a here. That's that guy. So if we add those things up, 9a plus 4, that will be 4a, will be 13a minus 12a, that will be just a. So it means that a is equal to 1. From here, we have the constant term. What are the constant terms we have? 6a plus 9b, that guy, and minus 12b, and minus 4a, plus 4b. And to organize this, we have 6a, 4a, that will be the 2a. This is plus 6 minus 4, that's 2. And the b term, plus terms 9 plus 4 is 13b, and minus 12b is this guy. So this one is just b, 13 minus 12 is b, sorry. And then the a is equal to 1. If we substitute here, we have 2 here, and then the b will be just minus 2. So we found a is equal to 1, b is equal to minus 2. So the non-homogeneous solution will be ax plus b, so 1x minus 2, e to the 3x. So this is a non-homogeneous solution, and the whole solution or general solutions for this equation is homogeneous part plus non-homogeneous part, and a homogeneous part ax plus bx, e to the minus 2x. That's a homogeneous part, and the non-homogeneous part is x minus 2 e to the 3x, as we calculated here. I will stop here. I will do a few more exercises on that in the next few videos. Okay, thank you very much.